Okay, so this is the 2025 spring semester rock and mineral review exam. This is the sneak preview, and I'm going to give you the answers right now. So, starting with number 1, I'm going to start for the first 10 are going to be the minerals. The first mineral, this is rose quartz. Very hard, hardness of a 7. Pink color gives it the distinction of being rose quartz. There are other quartzes, plus this milky quartz, crystalline quartz, and so forth, so you might see one of those next week. Number 2, this is a piece of biotite. It's one of the 2 micas you saw. There are several micas, but we only saw 2. We saw the muscovite, which is silver in color, and the biotite, which is black. This happens to be the muscovite, number 3. This is a silvery, flaky, very thin sheets, has basal cleavage, much like the biotite. The muscovite is a silver color, so that's the 2 micas. Number 4, this is rock gypsum, or just actually gypsum. It really is more of a gypsum, not a rock gypsum. It's not anhydrite, it's gypsum. Kind of a almost translucent color, very soft. You can scratch with your fingernails. Gypsum, nice sheets like this. Number 5, everybody's favorite, generically known as fool's gold. But this is actually pyrite. Nice crystalline form here. These are full of pyrohedrons. And this is actually pyrite. FeS2, iron sulfide. And this we saw in multiple colors, different forms. So here we have some green, we have some amber color, we have some octahedrons. Nice little crystalline form, cleat form actually. This is fluorite. Fairly soft, will not scratch glass. So this is fluorite, number 6. Number 7, common rock-forming mineral. This is potassium feldspar. We are lazy, so we call it K-spar. This has good cleavage. Basically on 2 sides, it has very vitreous luster on the cleaved sides. That is basically K-spar or potassium feldspar. We use the K because of the potassium on the periodic table is a K. This is kind of a tricky one, another rock-forming mineral. This is actually called hornblende or amphibole. Number 8 is hornblende or amphibole. Skipping over here to the table here to number 9. This reacts to acid, and the only thing that reacts to acid is going to be carbonates. This is calcium carbonate. This has very good cleavage. This is a really nice piece of calcite. Nice cleavage to it. 6120. And then number 10, this is magnetic. The only mineral that is magnetic we call magnetite. So that's number 10, magnetite. And that precludes the minerals, and now we know go to igneous rocks, which are the more difficult rocks to identify. This black one here is fairly simple though. It's got a glossy texture, very black in color. This is obsidian. There's brown obsidian and there's snowflake obsidian that we've seen. Number 12, this is full of holes. This is vesicular or scoria basalt. Definitely full of holes. This is because the magma was rich, and when the magma came to the surface, we call it lava. That lava happened to be very rich in volatile gases, and they escaped, expanding the surface of the rock, creating these little air holes. Number 13, kind of a tricky one. This is full of amphibole. Small little amphibole crystals in here. This is basically a porphyritic basalt. Number 14, the largest textural rock we'll ever see, crystalline rock. This is actually a pegmatite. It's a granite pegmatite full of muscovite, full of potassium feldspar and quartz. That is a typical pegmatite. We call it pegmatite granite or pegmatitic granite. Number 15, very dark crystalline rock. Has very visible minerals to it, so it's basically got a phanerotic texture to it. This is number 15, and this is gabbro. So gabbro. Number 16, I told everybody to pay attention to the green part. This is ultramafic. This is what we call dunite or peridotite. The mineral that makes up this rock is basically olivine, but we do call this a dunite when it's an igneous rock. Number 17. An igneous rock with no visible minerals whatsoever. This cooled at the surface very quickly. This is a rhyolite. So number 17 is a rhyolite. We're now going to move to the other side of the room and continue our numerical sequence to number 18. And number 18 has very prominent crystals of potassium feldspar or case bar. This is a porphyritic granite. We call it porphyritic because it has a one large phenocryst case bar. It's larger in comparison to the other minerals like the biotite and the quartz. So that is basically a good example of a granite porphyry, and that's what we call that, porphyritic granite. This rock here is very lightweight, very fine holes in it. This is what we call a frothy texture. This is actually pumice. So number 19 is a pumice. It was once part of obsidian. It was obsidian, and then as this obsidian had gas bubbles in it, the gas expanded the rock. It basically drastically increasing the surface area of the rock, pushed it out and made it kind of like a lighter color and very lightweight also. And this is basically a felsic rock, and so is obsidian a felsic rock, and that is pumice. Number 20. This rock is half mafic and half felsic, so it has half iron-rich minerals and half quartz-rich minerals. The two minerals that make up this rock are going to be amphibole and plagioclase. They're very light-colored plagioclase. This number 20 is a diorite. Now the sedimentary rocks. Number 21. A bunch of shells all clumped together. This is basically a coquina. Bunch of shells all clumped together, coquina. You find a lot of this in the state of Florida. Florida is basically all coquina. Number 22, very thin layered. This is definitely a limestone. Reacts to acid, so anything that reacts to acid, I told you it reacts to acid, so you didn't have to drop acid on it. Another rock that reacts to acid is going to be number 23 here, and this is chalk. Very soft, very lightweight, reacts to acid, but I don't want people putting acid on it because it would turn that white chalk into yellow chalk. So that is chalk. Number 24 is sedimentary rock that consists of sand grain material. So the grain size is sand. The red color is due to hematite, which is iron oxide, so that we call this a hematitic sandstone. Number 25. This is basically a generic shell. We can call it mudstone, claystone, siltstone. I like to lump everything into shell. I'm not going to split hairs there. So number 25 is shell. Number 26, another sand-sized material. People have actually dropped acid on this in the past, which is why I don't like to people put acid on things anymore. This is actually a rock that has sand-sized grains. This is a quartz sandstone. So number 26 is a quartz sandstone. 27. This rock has square gravel pieces clumped together. We call this a breccia. So when the clast fragments are square, we call it a breccia. And the cousin to the breccia is the conglomerate. So when the clast fragments are rounded, we call that a conglomerate. So we have a conglomerate and a breccia side by side. This is a sedimentary version of quartz. This is actually jasper. So there's three quartz minerals that occur in the sedimentary environment. One is chert, which is kind of a gray color. The other one is flint, which is black. This happens to be jasper. So number 29 is jasper. Number 30 is coal. We just can't call it coal. We have to call it bituminous coal. This is a sedimentary version of coal. It's not quite as compact as the anthracite coal. The anthracite coal is more pure carbon. This has a lot of sulfides in it, and actually sulfur in it, and organic material. This burns very dirty as compared to the anthracite coal, which burns very hot and clean. Now we go to the metamorphic rocks. So the first four metamorphic rocks here are going to follow the metamorphic grade. We're going to start first with Fred Flintstone's boss, which is slate. So Mr. Slate was Fred Flintstone's boss. And this is a slate, compact rock, layered, no minerals. Its parent rock is a shale. That's slate. The next grade in metamorphism is a rock with a little bit of a wavy texture, but still no visible minerals. The shine is due to quartz and muscovite trying to come out. This is actually a phyllite. So phylites have a little slightly wavy texture, a little slight shine to them. That's a phyllite. Next in the metamorphic grade, the first rock that actually has visible minerals in it is going to be a schist. This schist actually has some garnets in it too. You can see these little red things in here. Those are garnets. So that's a schist. Number 33 is a schist. Now moving across the room again to finish the rest of our metamorphic rocks. We go to number 34. The highest grade of metamorphism is a gneiss. You can see this gneiss is well banded. It consists of amphibole and potassium feldspar. So K-spar and amphibole make up that rock, number 34. Number 35, this is a layered rock, it's foliated. This we actually call green schist. So there's green schist and green stone. The green stone does not have foliation. This rock is well foliated, green color. We call it a green schist. This is actually the green stone. Not foliated as much, more compact. This is green stone. I know some people have a hard time seeing this as green, but it is green. Different lights show it. Next we go to number 37, a very, very hard rock consisting of quartz. Its parent was a quartz sandstone. Quartz sandstones, when metamorphosed, they become quartzite. So this is a quartzite. And this is now number 38. This is the sedimentary equivalent of bituminous coal. This is anthracite coal or anthracite coal. Very compact. All the impurities, all the organic material has been driven out of this due to heat. More compacted. If you were to compact this even more, you actually form a diamond. So this is almost pure carbon. This is a very preferred version of coal. It burns very hot, not as pollutant as the bituminous coal. So number 38 is anthracite coal. Number 39 reacts to acid. Nice crystalline structure to it. This actually came from the Marble Mountains in California. I actually picked this up over there. This is actually a piece of marble. Came from the Marble Mountains. What a coincidence. So marble reacts to acid. It forms a little bit more coarse crystalline structure. The parent of a marble was a limestone or a carbonate rock, and that's marble. And the last metamorphic rock, the last rock in this test, is a conglomerate that has been cemented together. This is what we call a metaconglomerate. So it's a metamorphic version of a conglomerate, very well cemented, very well fused, put under heat and pressure, and that ends our 2025 rock and mineral exam. So hopefully you can watch this on YouTube. If I went too fast, you can always pause the video. You have that power on YouTube. I just wanted to get this done before this camera went blank on me. So I'll see you later.